Hello dear students, our next question is, the electronegativities of nitrogen, silicon, carbon and phosphorus are such that. So student, in this question, if we will talk about the electronegativity, then nitrogen has electronegativity value 3.0, carbon has electronegativity value 2.5, silicon is 1.9 and phosphorus has electronegativity value 2.1, right? So basically you can say that nitrogen is highest electronegative element among these, right? After that carbon and then phosphorus and then silicon. This is the electronegativity order of these elements. So nitrogen, carbon, phosphorus, silicon. Option 3 is the correct answer. Thank you.
Hello my dear students, now coming to the next question, and the next question is, the lengthenoid contraction is responsible for the fact that, it means when lengthenoid contraction comes out to be in the 4th and 5th period, what happened? So lengthenoid contraction is responsible for the fact that, it means among all the 4, which statement for the correct for the lengthenoid contraction? So first option will be zirconium and yttrium. Zirconium and yttrium have about the same radius. This is the wrong option, because as we know, this will be the comes out to be the 4D period, and 4D yari zara niba maut tak. It means it will comes zirconium and yttrium have about the same radius. This is the wrong statement, as becomes when we goes from left to right in a period, the radius ratio will be the decreases. So the first option will be the wrong option. Coming to the next, zirconium and niobium have similar oxidation state. This is also a wrong statement, because there will be the different electrons found in the different elements. So oxidation number will be increases in zirconium to niobium. So they have different oxidation states. So this is also a wrong statement. Coming to the next, zirconium and hafnium have about the same radius. It will be the correct option, because in 4D and 5D period, in 4D and 5D period, as we know, the elements will be in 4th and 5th period. As we know, scandium, and in the 4D, which will be started from yttrium, and scandium, yttrium, and the 5D series will be started from the lanthanum. After lanthanum, there will be here will becomes zirconium, and after lanthanum there will becomes hafnium. So if we consider this will be 4D and this will be the 5D elements, there will be after lanthanum the electron will be goes in 4f period, or we can say 4f subshell. So 4f subshell will be filled before filling in 5D series. So zirconium and hafnium, due to the lengthenoid contraction, or we can say 4f, due to the 4f subshell, there will be length size of the elements continuously decreases, and it will be comes out to be zirconium as hafnium. It means its radius will be 159 picometer, almost 160 picometer, and its radius will hafnium has the radius almost 159 picometer. It means these both have the same radius ratio, because zirconium and hafnium, after filling of 4D orbitals and 5D orbital, there will be comes out to be lengthenoid series, which element size will be decreases in up due to the lengthenoid contraction. So the third option, zirconium and hafnium have about the same radius, will be the correct statement for the lengthenite contraction, and zirconium and zinc have the same oxidation state. This is also a wrong statement. So the third option will be our correct option among the four. Thank you.
Hello dear students, so our next question is, which one of the following has no unpaired electrons, right? First species is O2 minus. Student, O2 minus is contains 17 electron, and if a species contains 17 electrons, then that species has some amount of electrons which is unpaired, and that species shows paramagnetic behavior. O2 plus contains 15 electron, so it also has some amount of unpaired electron and it shows paramagnetic behavior. Next is O2 2 minus. O2 2 minus contains 18 electron and it doesn't have any unpaired electron, that's why it shows diamagnetic behavior. Next is O2. O2 contains 16 electrons, it has some amount of electrons which is unpaired and that's why it shows paramagnetic behavior. So, which of the following has no unpaired electron? So, option 3 is the correct answer, that O2 2 minus has no unpaired electron because it shows diamagnetic behavior. Thank you. Hello dear students, our next question is, the least reactive form of hydrogen is, right? Student, if we will talk about the least reactive form of the hydrogen, first one is H2, second nascent hydrogen, third is atomic hydrogen. Nascent hydrogen and atomic hydrogen are more reactive than H2, right? Because H2 is contained bond between hydrogen and hydrogen. So due to very strong hydrogen-hydrogen bond, it will be least reactive, and nascent hydrogen and atomic hydrogen will be more reactive. So option 1 is the correct answer. This is the least reactive form of hydrogen due to a strong bond between hydrogen and hydrogen. Thank you. Hello dear students, our next question is, which of the following species is prepared in Kastner-Kellner cell? Student, basically to prepare NaOH solution by electrolysis of NaCl in Kastner-Kellner cell, that process is known as Kastner-Kellner process. So we can say that by the electrolysis of NaCl aqueous solution, we will prepare NaOH in Kastner-Kellner cell. So this method is used to prepare NaOH. Option 2 is the correct answer. Thank you. Hello dear students, our next question is, which of the following is not correct for alkali metals? First one is low melting point. Student, yes, alkali metals has low melting point, and when we will go top to bottom in a group, then melting point also decreases. So this fact is true for the alkali metals. Their ions are isoelectronics with noble gases. Yes, their ions are isoelectronics with noble gases. For example, Li plus is isoelectronic with helium, right? And Na plus is isoelectronic with neon. Similarly, K plus is isoelectronic with argon. So yes, their ions are isoelectronic with noble gases. This is the true fact. Next is, they are good reducing agent. Yes, alkali metals are the metal which can donate their electrons very easily because they want to attain noble gas electronic configuration. So if they releases electron very easily from their outermost shell, then we can say that it can behave as reducing agent. So yes, they are good reducing agents. Next is high ionization energy. Student, when in a period, if we will talk about the period, then in a period alkali metal has lowest ionization energy because it can release their electron from the outermost shell very easily and with a very low amount of the energy, right? So that's why this is not the correct. Alkali metals has low ionization energy across a period. So option 4 is the correct answer and incorrect statement. Thank you. Hello dear students, so our next question is, boron halides behave as Lewis acids because of their dash 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 nature. Student, this is our boron halide BX3. BX3 is our boron halide, right? And if we will talk about the boron, boron has atomic number 5 and electronic configuration is 1s2, 2s2, 2p, 2p1. Now you can say that in the outermost shell, boron has 3 electrons and these 3 electrons are paired with the electrons of the halocene, right? So totally, boron now has 6 electrons in their outermost shell. But any element want to attain stability and they want to attain stable electronic configuration of noble gases. So they want to complete their octet by filling 8 electrons in them, right? So if it has only 6 electrons in the outermost shell, that means it has electron deficient nature because it contains 1 p vacant orbital. And if it has 1 p vacant orbital, then it can behave as a Lewis acid. So yes, boron halide behave as a Lewis acid due to their electron deficient nature because it doesn't complete their octet, right? So option 3 is the correct answer. It has vacant orbital, doesn't complete their octet, that's why it will behave as Lewis acid. Thank you. Hello dear students, our next question is, here we have silver and it react to the NaCN, 0.5% solution of NaCN with amount of the oxygen. And we will obtain a soluble complex A and this soluble complex A react to the zinc and we will obtain the complex B with silver. So basically we have to tell the A, B and the process name about, we have to tell that which is correct for the above reaction. So now student, when Ag react to the NaCN, then a soluble complex is formed and this soluble complex is NaAgCN whole twice. And when the soluble complex A is react to the zinc, then basically what happens, this zinc replaces silver. This zinc replaces the silver and the second complex is formed. And this complex B is formed. This is our complex B. So now you can see that option A1 is A is equal to this complex, which is correct. B is equal to this complex, which is also correct. And the third one is oxidation reduction process. So yes student, this process is oxidation and reduction process. In this process, redox reaction is proceed, right? You can see first here silver has 0 oxidation state. But after the complex formation, this CN has +1 oxidation state. And when this complex react to the zinc, then you can see that again silver has 0 oxidation state, right? So first oxidation is proceed and after the oxidation again reduction is proceed, right? So this process is oxidation reduction process. So option 4 is the correct answer. All of these statements are correct. Thank you.
Hello my dear students, now coming to the next question, and the next question is deep sea divers used to respirate in a mixture of. When scuba divers or deep sea divers goes to the sea underwater, what is the mixture of gases they are bringing with them? So the first option, oxygen and helium, oxygen and argon, oxygen and helium and nitrogen, oxygen and nitrogen, oxygen and hydrogen. As we know, the scuba divers when goes to the sea, they takes oxygen, helium and nitrogen. In the ratio of oxygen will be 32% and 11.2% of helium, and all remaining gases will be the nitrogen. So in this ratio they will be taken as a cylinder, they taken the cylinder in the ratio of this, because helium gas will be taken due to the dilution of nitrogen, because if the helium gases does not taken in the cylinder, there will be bends will be created for the scuba divers, and many times they are died due to the bends create among their bodies. So helium gas will be diluted the nitrogen gas, so the nitrogen gas will be easily excrete from the body. So there will be the second option will be our correct option, and this is the fact based question. So thank you.
Hello dear students, our next question is, here we have chromite ore, and this chromite ore react to the Na2CO3 in presence of oxygen, then we will obtain A, and this A will react to the concentrated H2SO4 and we will obtain B. So here anions represents in A and B are. Student, this is the structure of chromite ore FeCr2O4. It will react to the Na2CO3 in presence of oxygen. Then here we will obtain Na2CrO4 compound. And when it reacts to the concentrated H2SO4, then here formation of Na2Cr2O7 will take place, right? So now student, you can see that here anion A is CrO4 minus 2 and here anion B is Cr2O7 minus 2. This is your anion B. So option 2 and 3 is the correct answer and option 4 is the correct answer, both 2 and 3. Thank you. Hello dear students, our next question is, given below are two statements, statement 1 and statement 2. In the light of the above statements, choose the most appropriate answer from the options given below, right? So now statement 1. Valence bond theory explain the color exhibited by coordination compounds. Student, valence bond theory explain the hybridization and geometry of the compound, and valence bond theory can explain that complex is inner orbital complex or outer orbital complex, but it will not explain the color of the coordination compound. Color of the coordination compound explained by the DD transition theory. Color of the complex explained by the DD transition theory, not by the VBT. So this is false statement, incorrect statement. Statement 2. CFT considers the metal ligand bond to be ionic from electrostatic interactions between the metal ion and the ligand. Second statement is true. Crystal field theory basically explain the formation of complex by electrostatic attraction between metal and ligand, right? So first statement is incorrect, but second statement is correct. Option 4 is the correct answer. Thank you. Hello dear students, our next question is, the oxidation state of iron in brown complex FeH2O5NOSO4, right? Student, in this complex SO4 has -2 oxidation state. That means this complex has +2 oxidation state, right? So iron H2O5NO and this complex has +2 oxidation state. And here we have to identify the oxidation state of iron. So let it be X oxidation state of the iron. H2 is a neutral ligand. H2 is the neutral ligand. So if it is a neutral, then it has 0 oxidation state, right? And here we have nitrosinium. And this NO, this nitroso group has +1 oxidation state. So X plus 1, which is equal to the +2. So after the solving this, we will obtain X is equal to +1. That means iron has +1 oxidation state in this brown complex. So option 1 is the correct answer. Thank you. Hello dear students, so our next question is, which of the following has E configuration? We have to identify the E configuration for these following alkenes, right? So first of all, according to the CIP rule, we have to prioritize these groups which is attached on the double bonded carbon atom, right? So into the first alkene, you can see we have this C2H5 and hydrogen on this carbon atom, and we know that hydrogen atom has less atomic number than carbon, so that's why this C2H5 have more priority than hydrogen. And into the CH3 and hydrogen, again CH3 has more priority than hydrogen because hydrogen is have least atomic number. Now you can see that this compound has JED configuration, right? Because both the high priority group are present to the same side, so that's why this alkene has JED configuration. Now coming to the next, into the second. Now here we have bromine and carbon, and we know that bromine has more atomic number, that's why it will obtain more priority. Now at this double bonded alkene we have two groups, CH3 whole twice and CH2 CH3. Now student, you can see that first atom is same, carbon and carbon. Second atom is also same, hydrogen, and here also hydrogen. But third atom here is carbon, and here third atom is again hydrogen. And we know that carbon has more priority than hydrogen, so that's why this compound, this group will obtain more priority. And you can see that this alkene is also have JED configuration. So if first and second, if first atom is same, then we will go to the next atom, and if second atom is also same, then we will go to the next atom, right? So basically we will go to the next atom when we will not identify any differentiation, right? Now the next is third. In the third, hydrogen and deuterium both have same atomic number because these are isotopes of each other. So now we will compare to their atomic mass, and we know that atomic mass, deuterium has more atomic mass than hydrogen, so it has more priority. Now bromine and chlorine. Into bromine and chlorine we know that bromine has more atomic number, so it will obtain more priority. Here high priority group are present opposite sides, so this alkene has E configuration. So option 3 is the correct answer. This alkene, this compound has E configuration. Thank you. Hello dear students, so our next question is, which of the following reactions will yield 2,2-dibromopropane, right? First reaction is alkyne, and this alkyne will react with the two molecules of HBr. This is alkyne, CH3C triple bond CH plus HBr. Student, here alkyne has pi bond. So first of all, this reaction is undergo by electrophilic addition reaction, right? And this electrophilic addition reaction will undergo by following the Markovnikov rule. And Markovnikov rule says that electrophile will go to that carbon atom which have more number of hydrogen. This carbon atom has more number of hydrogen, so electrophile will go to that carbon atom which have more number of hydrogen. And here Br. Again we have two molecules of HBr, so one molecule will another molecule will go to the addition on this double bond, and now you can see here that this alkene will follow again Markovnikov rule, and Markovnikov rule says that electrophile will go to that carbon atom which have more number of hydrogen. So hydrogen is our electrophile here, so hydrogen will go again to this carbon atom, and here bromine, right? And you can say we will obtain 2,2-dibromopropane as a major product of this reaction sequence. So option 1 is the correct answer. Now coming to the next, CH3CH double bond CHBr plus HBr. Student, if we will talk about this reaction, CH3CH double bond CHBr, this reaction will undergo by the electrophilic addition reaction, right? By the electrophilic addition mechanism, and in the electrophilic addition mechanism, carbocation is formed as the intermediate of the reaction. So reaction is proceed by the formation of more stable carbocation, right? So pi bond will attach to the vacant orbital of H plus and Br minus will releases, and formation of this carbocation will take place. This carbocation is more stable than formation of this carbocation, because this cation will obtain d orbital resonance, will obtain the back bonding by the lone pair of the bromine atom, right? So that's why this carbocation is more stable. So now our electrophile will come to the, will attach to that carbon which can form more stable carbocation. So final product will be CH3, CH2, CH, Br, Br. This is not 2,2-dibromopropane, this is 1,1-dibromopropane. Next is CH triple bond CH, two molecules of HBr. So in this reaction, we will obtain CH3CH Br2. This is not propane, this is ethane. Here is alkene, and alkene will react to the HBr by following the Markovnikov rule, and Markovnikov rule says that electrophile will go to that carbon atom which have more number of hydrogen. So we will obtain here CH3 CH3. This is 2-bromopropane, right? So option 1 is the correct answer. Thank you. Hello students, so our next question is, which one of the following statements regarding photochemical smog is not correct? First statement is, CO does not play any role in photochemical smoke formation. Yes, CO does not play any role. This is a true statement, right? Because photochemical smoke occurs by the hydrocarbon and nitrogen oxides. So CO does not play any role to the formation of photochemical smoke. Second is, photochemical smoke is oxidizing in character. Yes, this is a true statement. Photochemical smoke is also known as oxidizing smoke because it has oxidizing character. Next is, photochemical smoke is formed through photochemical reaction involving solar energy on the hydrocarbon. So this is a true statement, right? Because photochemical smoke contains hydrocarbons, so it occurs by the photochemical reaction involving solar energy on the hydrocarbon. Next is, photochemical smoke does not cause irritation in eye and throat. Student, this is the false statement because photochemical smoke causes irritation in eye and dryness in the throat, right? So option 4 is the correct answer and this is incorrect statement. Thank you. Hello dear student. So our next question is, the distillation technique most suited for separating glycerol from spent lye in soap industry is. In soap industry, to separate the glycerol from spent lye, we will use distillation under reduced pressure, right? And this technique is used to separate a mixture which having high boiling point, but can decompose at or below their boiling points. That type of mixture can be separated by the distillation under reduced pressure, and this technique is used to separate glycerol from spent lye. Thank you. Hello dear students, so our next question is, below is the substitution reaction in which CN replaces Cl. RCl with KCl, we will obtain RCN plus KCl. So to obtain propane nitrile, RCl should be, student, you can see in this reaction sequence we have alkyl chloride and it will react to the alcoholic KCl and we will obtain RCN, alkyl nitrile group, right? So in this reaction, one carbon group is increases and this carbon group belongs to the CN group, right? That means if we want to obtain propane nitrile, that means we should use the alkyl halide with the 2 carbon atom, because by this reaction immediately the carbon of the CN group increases and it will become propane from the ethane, right? So we will use here C2H5Cl and this reaction is proceed by KCN, alcoholic KCN, and reaction using the SN2 mechanism and we will obtain here C2H5CN. Now you can see we have 3 carbon atom, 1, 2, 3, and we have this cyanide group also as a PFG. So the name of this compound is propane. Name of this compound is propane nitrile, right? So basically our RCl should be chloroethane. It will be chloroethane, right? Option 1 is the correct answer. Thank you. Hello dear students, so our next question is, match list first with list second. Here we have list first reactions and in the list second we have products formed in reactions. First one is Reimer-Tiemann reaction. Student, into the Reimer-Tiemann reaction we will take phenol and this phenol will react to the chloroform in presence of a base. Then here formation of salicylaldehyde. Then formation of salicylaldehyde will take place. Second is hydrocarbon oxidation. In the hydrocarbon oxidation, suppose we have alkane and when this alkane will oxidize then formation of alcohol will take place. C is Williamson ether synthesis reaction. Into the Williamson ether synthesis reaction, we will take alkyl halide and this alkyl halide will be primary alkyl halide. And this primary alkyl halide will react with the alkoxide ion. When it reacts to the alkoxide ion, then formation of ether, ROR dash, then formation of ether will take place. And the D is coal-base reaction. Into the coal-base reaction, we will take phenol, and this phenol react to the with the carbon dioxide in presence of a base NaOH. Then here formation of salicylic acid will take place, right? So now student, you can see Reimer-Timan reaction with salicylate A is matched with the second. Hydrocarbon oxidation reaction, alcohol B first. Williamson ether synthesis formed ether, and coal-base formed salicylic acid. So option 2 is the correct answer. Thank you. Hello dear students, so our next question is, arrange the following compounds in increasing order of COH bond length: methanol, phenol and para-ethoxyphenol. Student, this is the structure of methanol. Next one is phenol. And the next one is para-ethoxyphenol. Into the methanol, you can see we have carbon oxygen, and into the carbon oxygen any resonance are not present. So if resonance are not present, then bond length will be higher. But into phenol, you can see oxygen atom is contain lone pair, so due to the lone pair, and it will take participate into the resonance. So due to the resonance, bond length, due to the resonance in this carbon oxygen bond, double bond characteristics will come. And due to the presence of double bond characteristics, bond length will be decreases. So methanol has highest bond length. Methanol has highest carbon oxygen bond length than phenol and then para-ethoxyphenol, right? Due to the absence of resonance. Now coming to the phenol and para-ethoxyphenol. Into the para-ethoxyphenol, you can see here ethoxy group are present. So if ethoxy group are present, which is also contain the lone pair, so lone pair of this oxygen will also take participate into the resonance, right? So basically in this ring, two resonance are present with the OH group and with the ethoxy group. So due to the presence of two resonance, here in this bond, in this carbon oxygen bond, double bond characteristics will be less comparatively phenol due to the poor resonance of this OH group. So if double bond characteristics will be low, then it has more bond length comparatively phenol. So para-ethoxyphenol has more carbon oxygen bond length than phenol because it has poor resonance. Because it has poor resonance with the OH group, that's why double bond characteristics will be low, and that's why here bond length will be increases. But in the phenol, only one resonating groups are present, so that's why here resonance will be present in more amount in this carbon oxygen bond. Double bond characteristics will come more amount, and that's why it has less bond length, right? So now you can see methanol, para-ethoxyphenol and phenol. Option 3 is the correct answer. Thank you. Hello dear students, so our next question is, in the reaction sequence we have to tell the product of this reaction. You can see first of all we have acetaldehyde and it will react to the HCN in presence of basic medium. Student, this is the CH3 C double bond OH and this compound will react to the HCN. Here nucleophilic addition reaction will be proceed, right? Here nucleophilic addition reaction will be proceed, and into the nucleophilic addition reaction cyanohydrine is formed as a product in this reaction sequence. You can see this carbon atom is sp2 hybridized and the structure of this carbon is trigonal planar. The structure of this carbon is trigonal planar. Cn minus is our nucleophile which take at this carbon and the bond will shift to the oxygen. So we will obtain here CH3 COH HCN. Because this carbon atom is sp2 hybridized and the structure is trigonal planar, so Cn minus nucleophile can take from the below the plane and above the plane, right? So we will obtain the racemic mixture of this product. We will obtain the racemic mixture of this product when Cn come here and CH3. This is our product A. Now this product will undergo hydrolysis in presence of acidic medium. So basically what happened, this cyanide group will undergo hydrolysis, and when it will undergo hydrolysis, carboxylic group is formed as a final product of this reaction sequence. This is a product of this reaction sequence. This is a mixture of the product, and option 3 is the correct answer. Thank you. Hello dear students, our next question is, in the given sequence of reaction, you can see we have this compound, and this compound will react to the acidic anhydride, and we have to tell the product A of this reaction sequence, right? So now student, this is CH3 NH2. It will react with the acidic anhydride CH3 C double bond O, O C double bond O CH3. Because nitrogen atom is contain lone pair, so it will behave as a nucleophile, will attack at this electrophilic side, and the bond will shift to the oxygen. So finally we will obtain here CH3 NH C double bond O CH3. This is our product A. Now this compound will further react to the Br2 in presence of acetic acid. Student, in this reaction we have nitrogen atom which contain lone pair, and it will take participate into the resonance with the benzene ring, and it is ortho-para-directing in nature. So because here it is ortho-para-directing in nature, so bromine plus electrophile will come at the ortho and para position, but you can see that para position is already blocked with the methyl group, so it will come at the ortho position. It will come at the ortho position with respect to the nitrogen, right? And this is your product P. Now this compound will undergo hydrolysis. This compound will further undergo hydrolysis in presence of acidic medium, right? So when it will undergo hydrolysis, then what happen? We will obtain finally CH3 NH2Br. We will obtain this product as a major product of this reaction sequence, and this is our C. Now you can see option 2 is the correct answer. Thank you. Hello students, our next question is, synthetic rubber is. Student, neoprene is known as synthetic rubber, and this synthetic rubber is formed by the 2-chloropene. This is 2-chloropene. So student, by the polymerization of this 2-chloropene, by the polymerization of this 2-chloropene, we will obtain neoprene. We will obtain this neoprene, and this neoprene is also known as polychloropene. This neoprene is also known as polychloropene, and this is known as synthetic rubber. So option 2 is the correct answer. Student, polyisoprene is a natural rubber. Polythene and polyester. Polythene is a synthetic plastic, and polyester is used as synthetic fiber. Thank you. Hello dear students, our next question is, aspirin is known as. Student, if we will talk about the aspirin, this is a structure of aspirin. Here OH, this is the structure of aspirin. C double bond O CH3. We know that aspirin is used as antipyretic or analgesic drug, and this is the structure of aspirin, and this aspirin is also known as acetyl salicylic acid. This is also known as acetyl salicylic acid. This is a common name of the aspirin. So option 4 is the correct answer, acetyl salicylic acid. Thank you.
So students, the next question is from the mole concept. The question is, for the reaction is A plus 2B gives C, and we have 5 moles of A and 8 moles of B, and we have to determine that how many moles of C are produced. So here it is A plus 2B gives C, 5 moles of A and 8 moles of B. So first we are going to determine the value of limiting reagent, or you can say that limiting reactant. Now what we are going to do, we are going to divide, or we can find out the ratio of the given moles and stoichiometry, and the value is lower for this ratio will be the limiting reactant. Now first we are going to apply it for A. For A, the given number of moles are 5 and the stoichiometry are 1. So the value is 5. While if we talk about B, then the given number of moles are 8 and the stoichiometry is 2. So this value is simply 4. Now here, as we clearly observe that B is the limiting reagent. So here B is the limiting reagent. And now the chemical procedure or chemical calculations will occur according to the limiting reactant. So here 2 mole of B will produces only 1 mole of C. Clear? Now we have 8 moles of B, so definitely 8 moles of B will produces 4 moles of C only. Hence option number 2 is the correct choice here. So students, the next question is from the atomic structure chapter. The question is, according to the Bohr theory, which of the following transition in the hydrogen atom will give rise to the least energetic photons? The least energetic photons is where the energy shell difference is lesser, and when we move above the energy shells, the consecutive differences between the two energy shells is lesser, will be decreases, or you can say that decreases. So the least energetic photon is releases in the 6 to 5 transition, because 6 to 1 is the maximum energy photon will releases, then 5 to 3, then 5 to 4, and the least releases from 6 to 5. Hence option number 1 is the correct choice. So students, the next question is from the gaseous state, and the question is, a bottle of dry ammonia. A bottle of dry ammonia means basically we have NH3 here, and a bottle of dry hydrogen chloride means HCl. Clear? Connected through a long tube are opened simultaneously at both the ends. So basically we have a tube here. This is, suppose this is the tube, and we have NH3 gas from the one side and HCl gas from the other side, and both the ends are open simultaneously. The white ammonium chloride, as we know that if both are chemically react, then NH4Cl are produces, which is white fumes in color. Clear? So the white ammonium chloride ring first formed will be, we have to find out basically this chemical reaction will occurs at which side. So here we know that according to Graham's law of diffusion, rate of diffusion is inversely proportional to under root of molar mass. So higher will be the value of molar mass, lower will be the rate of diffusion. And here the molar mass of ammonia is simply 17, and for HCl it is 35.5. So the lower molar mass is for ammonia. So ammonia will travel more than the half part here, while HCl will only slightly diffuse slightly here. Clear? So this is the reason where NH4Cl white fumes will appear. So we can say that it will appears near the HCl bottle. So near the hydrogen chloride bottle is the correct option here. Hence option number 2 is the correct choice. So students, the next question here is assertion and reason based thermodynamic question. The question is, a process is called adiabatic. Adiabatic means the value of Q is equals to 0, rest anything will be changed. A process is called adiabatic if the system does not exchange heat with the surrounding. Yes, this is correct. Q equals to 0 means the system, there is no exchange of heat in between system and surrounding. So definitely the assertion is correct. Now the reason is, it does not involve increase or decrease in temperature of the system. No, this is wrong. Only heat exchange is not possible. Rest anything can be changed. Either it is pressure, volume, temperature, anything will be changed. Hence we can say that reason is correct. So reason is incorrect. So assertion is correct, but reason is not correct. Hence option number 3rd is the correct choice. So students, the next question is from the thermodynamics chapter. The respective examples of extensive and intensive properties. So we have to find out that which option will contain respectively extensive and intensive property. As we know that all the chemical properties are classified into two categories, that is extensive and intensive. The physical properties which depends upon the number of particles are called extensive, while which do not depends upon the number of particles are called intensive. So here the entropy is the extensive property because it highly depends upon the number of particles, while temperature is an intensive property because it do not depend upon the number of particles. So basically this is the memory based question, hence option number 3rd is the correct choice. So students, next question is from the chemical equilibrium. The question is, Kp is how many times equals to Kc for the given reaction. So the reaction is given here, and we know that the formula used here is Kp is equals to Kc RT ki power delta Ng. Now delta Ng is equals to summation of gaseous stoichiometry of product minus summation of gaseous stoichiometry of reactant. Now put the values here. The product is, that is ammonia, its stoichiometry is 2, while for the reactant the stoichiometry is 1 plus 3. So it is 2 minus 4. So the value of delta Ng is equals to minus 2. So this is the value of delta Ng here. Now put the value here. Kp is equals to Kc RT to the power minus 2. So Kp is equals to Kc upon R square T square. So basically Kp is 1 upon R square T square times of Kc, which is given in the option number 1. So students, the next question is from the ionic equilibrium. The question is the pH value of a solution whose hydroxide ion concentration is 6.2 into 10 raised to the power minus 9 mole per liter. So here basically the concentration of OH minus is 6.2 into 10 raised to the power minus 9. To find out the value of POH, we have to take negative log on both the side. So negative log of OH minus is equals to negative log of 6.2 into 10 raised to the power minus 9. On solving this, we get the value of POH is equals to 8.21, which is given in the option number 1.
Hello my dear students, now coming to the next question, and the next question is which of the following reaction is an example of a redox reaction. In the first reaction there will be gives XeF6H2O, XeOF4 and 2HF. In this reaction, as we seen here, xenon is found in the +6 oxidation state because there are 6 fluorine which has -1. Every fluorine has -1 oxidation state, so there will be -6 oxidation states of fluorine. Here hydrogen will be found in +1 and oxygen will be found in -2 oxidation state. In the product side, as we see that Xe is also found in the +6 oxidation state, oxygen has also -2 oxidation state and fluorine has -1 oxidation state. So there will be no change in oxidation states of all the reactions and product side because here hydrogen also +1 and fluorine has -1. So all elements in this reaction will be found in their native oxidation states. Now coming to the next option, so first option will be the wrong. Coming to the next, XeF6 plus 2H2. Xe is found in the +6 oxidation state and fluorine is -6. Here also hydrogen has +1 and -2 oxygen. So xenon also in the product side is found in +6 oxidation state and oxygen will be the, every oxygen will contain -2. So there will be the same oxidation state among all the 4 elements. Now coming to the next, in the third option, so second option will be the wrong option. Now coming to the next redox reaction, it will be xenon has +4 oxidation state and fluorine has -1 oxidation state. Total 4 fluorine are there, so there are -4. Now O2 F2. In O2 oxygen has +1 oxidation state and fluorine has -1 oxidation states. Now coming to the product side, in reactant side the xenon will be found in +4 oxidation state, but in the product side xenon will be found in +6 oxidation state, because there will be 6 fluorine are added in the product side. So +4 to +6, here will be change the oxidation state of xenon, and oxygen which will be in the +1 oxidation state will be goes to the 0 oxidation state. It means there will be redox reaction takes place in the third option. So third option will be our correct option. Now coming to the fourth option, there will be found in +2 oxidation state of xenon, and after that xenon also here we can look here, fluorine has -1 and xenon has +1, but there will be the +1 oxidation state also found in the after the bracket. So +1 and +1 is also +2. It means there will be xenon found in +2 oxidation state in the reactant side and the product side. As we know, fluorine phosphorus has +5 oxidation state in the reactant side, and the product side is also found in the +5 oxidation state. So the fourth option will be the wrong option, because all the oxidation state in the reactant and product side will be the same. So among all the four, the third option will be the correct option, and in third option there will be the redox reactions takes place. Thank you.
So students, the next question here is from the solid state. The question is, the radius of the Na plus is 95 picometer. So here the radius of Na plus ion is 95 picometer. Clear? And that of Cl minus is 181 picometer. The radius of Cl minus is 181 picometer. The coordination number of Na plus ions will be, basically the Cl minus ion will form the lattice here, and Na plus occupies the position in the octahedral void. So we must have to find out the limiting radius ratio here. So the value of limiting radius ratio is determined by using the relation of R plus radius of cation upon radius of anion. This is the value of limiting radius ratio. The limiting radius ratio for the cation here 95 value radius of cation, and radius of anion is 181. Clear? So on solving this we get 0.524, and the limiting radius ratio, if the limiting radius ratio is lie in between 0.414 to 0.732, it means what? It is in octahedral void, and the coordination number for the octahedral void is 6, because it is formed by 6 particles. Hence we can see that option number 2 is the correct choice here. So students, the next question is from the liquid solution chapter. The question is density of 2.03 m. So basically molality is given, that is 2.03. Aqueous solution of acetic acid. So the acetic acid solution it is, and its density is also given. So density of this solution is 1.017 gram per ml, and the molecular mass of acetic acid we know it is 60. Now calculate the molality of the solution. Now here we are going to apply the direct relation formula, that is molality is equals to 1000 m upon 1000 d minus m dot mb. So the molality is equals to 1000. The value of capital M is 2.03 divided by 1000, and the value of density is 1.017 minus again molality value is 2.03 into molar mass of solute, that is acetic acid, is 60. On solving this we get the molality 2.27 small m, which is given in the option number 1. So students, the next question is from the electrochemistry. The question is a 100 watt 110 volt lamp is connected in series with an electrolytic cell containing CdSO4 solution. The weight of cadmium deposited by the current for the current flow 10 hours. So the current flow will be in 10 hours. So basically, first we are going to determine that what is the value of current. Clear? So here the value of power in physics is determined by potential difference into current. So current is basically power upon potential difference. Here power is 100 watt and potential difference is 110. So this is the value of current which we are going to supply in the CDSO4 for 10 hours. So time here is 10 hours and we have to convert it into seconds. So 10 into 60 minutes into 60 seconds. So this is the value of time through which we can supply 100 upon 110 current. Now the atomic weight of cadmium is 112.4 and CDSO4, here CDSO4 will break down into CD plus 2 and SO4 minus 2. Clear? So basically the N factor for cadmium is what? It is 2. So its equivalent weight is what? Atomic mass. It is atomic mass upon N factor. Clear? So atomic mass is given already 112.4 and the N factor is 2. So this is the value of equivalent mass. Now we are going to apply the Faraday's first law formula. Clear? Faraday's first law of electrolysis. It is W equals to ZIT. W is equals to ZIT, or we can also write it W equals to Z. It is E by F into I into T. Now we are going to put down the value and get the answer. So W of that is the weight of cadmium deposited. The equivalent weight is 112.4 upon 2. It is 112.4 upon 2. The current value is 100 upon 110. The time value is 10 into 60 into 60 and the Faraday's constant is 96500. Now we are going to solve this. On solving this we get 19.06 gram of the cadmium deposited, which is given in the option number 1. So students, the next question is from the chemical kinetics. The rate of reaction is expressed in different ways as follows. So this is the way for the expression of rate. Now here positive sign is for the product, negative sign is for the reactant, and the number by which these are divided are basically the stoichiometry. So here the reactants are, negative sign is in D part and is in B part. So B, because it's divided by 1, so its stoichiometry is 1 and it is 3D. So B plus 3D gives, here A is 4A and C is 2C, and it is correctly given in the option number 2nd.
Hello dear students, our next question is, carbon suboxide C3O2 has recently been shown as a component of the atmosphere of Venus. Which of the following formulation represent the correct ground state Lewis structure for carbon suboxide? Right? Student, carbon suboxide are present in this structure. This is the structure of carbon suboxide and here nitrogen atom is contained 2 lone pair. Clear? Now student, you can see into the option 3. Option 3 is contained here this is 2 bond pair, 2 bond pair, 2 bond pair, 2 bond pair, and the nitrogen is contained here 2 lone pair, 1, 2, 1 and 2. So option 3 is the correct answer. This is the correct Lewis structure of carbon suboxide. Thank you. Hello dear students, so our next question is, which of the following gives propine on hydrolysis? Student, when we will do hydrolysis of magnesium carbide, Mg2C3, when this compound undergo hydrolysis, then here formation of C3H4 and magnesium hydroxide will take place. And the C3H4 exists in the form of propine. So option 4 is the correct answer, that magnesium carbide on hydrolysis gives us propyne as a product of the reaction. And this third one is Al4C3. Student, when this Al4C3 undergo hydrolysis process, then we will obtain CH4 methane as the product. So option 4 is the correct answer. Thank you. Hello dear students, our next question is, which one of the following oxides is expected exhibit paramagnetic behavior? Student, basically oxide which contain unpaired electron that exhibit paramagnetic behavior, right? So if we will talk about the odd electron species, then here we have ClO2 in the option, and ClO2 has odd electron species and contain one unpaired electron, right? And this is the ClO2. Now you can say the ClO2 is contain one unpaired electron, and due to this unpaired electron it shows paramagnetic behavior. So option 3 is the correct answer. But if we will talk about the CO2, SiO2 and SO2, these not contain any unpaired electron, right? For example, CO2, this is the structure of CO2. There is not any unpaired electron. In the SO2, again this is SO2 and it is not contain any unpaired electron. And the next one is SiO2. SiO2 is also not contain any unpaired electron, right? So now option 3 is the correct answer, because ClO2 is contain odd electron or unpaired electron, that's why it shows paramagnetic behavior. Thank you. Hello dear students, our next question is, which of the following ion is diamagnetic in nature? A student, an ion which shows diamagnetic behavior when it does not contain any unpaired electron, right? First one is scandium. Scandium has atomic number 21, but it shows +3 oxidation state, that means it contains 18 electrons, right? So scandium has electronic configuration equal to the noble gas argon. Now Cr+3. Chromium has atomic number 24, but because it contains +3 oxidation state, that means it contains only 21 electrons, right? So electronic configuration of Cr+3 is argon 4:2 3d1. Now you can see that this chromium+3 contain one unpaired electron, so it shows paramagnetic behavior. If a species contain any unpaired electron, then it will show paramagnetic behavior. Next is titanium+3. Titanium has atomic number 22, but because it shows +3 oxidation state, that means it contains 19 electrons, right? So electronic configuration will be Ar4s1. It contains one unpaired electron, that's why it shows paramagnetic behavior. Next is vanadium 2+. Vanadium has atomic number 23, because it donated 2 electrons, that means we can say that it has 21 electrons, and electronic configuration will be argon 4:2 3d1. You can see it has one unpaired electron, that's why it shows paramagnetic behavior. So only scandium+3 not contain any unpaired electrons, that's why it shows diamagnetic behavior. Option 1 is the correct answer. This is diamagnetic in nature due to absence of unpaired electron. Thank you. Hello dear students, our next question is, the number of unidentate ligands in the complex ion is called. Student, number of unidentate ligand in the complex ion is called coordination number. Basically, coordination number is the total number of electron pairs which is accepted by the central metal atom. So we can say that if number of unidentate ligand you can count, then you can count this total number of electron pair which is accepted by the central metal atom. So this is known as coordination number. Option 3 is the correct answer. Thank you. Hello dear students, so our next question is compare acidic strength. Student, we know that acidic strength is directly proportional to the stability of conjugate base. It is directly proportional to the stability of conjugate base. So first of all, in the first compound, when benzoic acid releases hydrogen, then this conjugate base is formed. Into the second compound, when phenol releases hydrogen, then this conjugate base is formed. Into the third, when this compound releases hydrogen, then this conjugate base is formed. And into the fourth compound, this conjugate base is formed, PHCH2O-, right? First of all, we know that negative charge will be more stable on the more electronegative atom. Here you can see we have oxygen, sp hybridized carbon, and then oxygen. And we know that oxygen atom has more electronegativity than sp hybridized carbon atom. So we can say that negative charge will be more stable on the oxygen atom than sp hybridized carbon atom. So first, second and fourth compound will be more acidic in nature than third, right? Now student, we have to compare into first, second and fourth. Into the first conjugate base, you can see that this negative charge will participate into the resonance, and by resonance the negative charge will come again at the oxygen atom. So that means after the resonance, negative charge will come on the more electronegative atom, and this is the, you can see, this is the equivalent resonance, and we know that equivalent resonance will be more stable. That's why this conjugate base is more stable, and that's why it has most acidic nature. So first is most acidic in nature, then second and fourth. Now we will compare into second and fourth. Into the second compound, this O- is formed, and this O- will participate into the resonance with the benzene ring. But here in this compound, resonance is not possible, because due to the resonance, stability of the negative charge increases. That's why it will be more acidic in nature. So second will be more acidic in nature, 4 than 3. This is the correct acidic strength order, and you can see that option 2 is the correct answer. Thank you. Hello dear students, so our next question is, which of the following alkyl bromides will eliminate HBr fastest, right? Students, suppose you have an alkyl bromide RCHBr CH3, and in this reaction sequence, this HBr eliminated, and the formation of this alkene will take place, right? So basically, if this product will be more stable, if this alkene will be more stable, then reaction will proceed with the fastest rate, right? So we have to take that alkyl halide which can form more stable alkene, right? Now coming to the ethyl bromide. This is ethyl bromide C2H5Br. When here HBr eliminated, then we will obtain CH2 double bond CH2, right? Now coming to the second, we have propyl bromide. Into the propyl bromide, when HBr eliminated, then we will obtain propene. Now the third is isopropyl bromide. When HBr eliminated, then we will obtain this propene. Fourth one is tertiary butyl bromide, right? So when HBr eliminated, then formation of this alkene will take place. Clear? Now student, you can see this alkene is stable by the 6 alpha hydrogen. This alkene is stable by the 3 alpha hydrogen. This alkene is stable by the 3 alpha hydrogen, and this alkene is stable by the not stable by any alpha hydrogen, right? So basically, the alkene which have more number of alpha hydrogen, that alkene will be more stable, and if the product is more stable, then reaction will proceed with the fastest rate. So option 4 is the correct answer. Tertiary butyl bromide will eliminate HBr fastest because it can form the more stable alkene. Thank you. Hello dear students, so our next question is, in the following reaction, the product E is. Now student, you can see we have glyceraldehyde, and this glyceraldehyde will react to the NaOH followed by hydrolysis. So when this compound is contain carbonyl group but not contain any alpha hydrogen. So when this compound which contain carbonyl group but not contain any alpha hydrogen treated with a base, then Cannizzaro reaction will be happen. So here Cannizzaro reaction will be proceed. Cannizzaro reaction will be proceed, and this compound is contain 2 carbonyl groups, so basically it will be intramolecular Cannizzaro. This reaction will be intramolecular Cannizzaro reaction. So into the intramolecular Cannizzaro reaction, one carbonyl group, one aldehyde group will oxidize into carboxylic, and the second will be reduced into alcohol. So it will be our major product E of this reaction sequence, right? Now student, you can see option 3 is the correct answer, because compound is symmetrical, so any CHO group can be oxidized and any one CHO group can be reduced. Thank you. Hello dear students, our next question is essential amino acids are. Student, essential amino acids are those acids which not form in our body, and it should be taken by the diet from the out sources, right? So leucine, lysine and tryptophan, these three are essential amino acids, so that's why option 1 is the correct answer. Thank you.
So students, the next question here is subshell designated by azimuthal quantum number L is equals to 3. L is equals to 3 means the D subshell, and F subshell. L equals to 3 means F subshell, and F subshell will contains maximum 14 electrons. You can also find out the number of electrons by using the formula, that is 2 into 2L plus 1. Now put here the value 2 into L, the value of L is 3 plus 1. Now solve it, we get 6 plus 1, that is 7, and 7 to J is 14. But as we all know that the number of electrons in S is 2, P 6, D 10 and F equals to 14. So the option number 1 is the correct choice here. So students, the next question here is from the thermodynamics chapter. It is a system absorbs 300 calorie. So basically we have a system and it absorbs, it means the value of Q is plus 300 calorie. Now of heat with result of the system becomes double of its initial volume. So the initial volume will be doubles. So let's suppose the initial volume is V and the final volume is, that is called V2, is 2 times of initial. Now and temperature changes from 273 to 546. So T1 is 273, T2 is 546 Kelvin. The work done by the system on the surrounding is 200 calorie. So work done by the system on the surrounding. So it means work done is negative here. So it is minus 200 calorie. Calculate the value of delta E. So here basically we have to apply the first law of thermodynamics, that is conservation of energy. Delta E is equals to simply Q plus W. Now put the values here. Delta E is equals to, the value of Q is 300, so it is plus 300, and the work done is minus 200 and units are in calorie. So delta E is equals to 100 calorie is the overall change in internal energy, which is given in the option number 3.
Hello my dear students, now coming to the next question, and the next question is given that the oxidation state of sulfur is -2, the equivalent weight of sulfur is. In this question we have given the oxidation state of sulfur is -2 and we have to calculate its equivalent weight. So as we know, the formula of equivalent weight is equal to molecular mass divided by valency factor. So the molecular mass of sulfur, as we know, the molecular mass of sulfur is equal to 32 and its valency factor, because there will given oxidation state is 2, so its valency factor is equal to 2. It means equivalent weight will be comes out to be 16. So the first option will be our correct option among all the four for the sulfur. So equivalent weight of sulfur will be 16. Thank you.
So students, the next question is from the electrochemistry, and the question is the chemical species undergoing reduction in dry cell is. So basically in dry cell the MnO2 will reduces into MnO3. So basically in dry cell the MnO2 is undergoing the reduction. So this is the memory based question. Option number 3 is the correct choice. So students, the next question is from the chemical kinetics. Which of the following represents expression for 3 by 4th life of first order? T 3 by 4th life means what? It means 3 by 4 part of the reaction is completed and the remaining part is only 1 by 4th. So AT is 1 by 4 times of A naught and initial concentration is A naught here. Now for the first order, the integrated rate law formula is K equals to 2.303 by T log A naught upon AT, and we have to put the values here. K equals to 2.3. We have to find out the time. So T 3 by 4 is equals to 2.303 by K log of, it is A naught upon 1 by 4 A naught. A naught to A naught will cancel out. So T 3 by 4 is equals to 2.303 by K log of 4, and it is given in the option number 3. So students, the next question is from the colloidal solution, that is the surface chemistry chapter. Gelatin is often used as an ingredient in the manufacturing of ice cream. The reason is for gelatin is basically the lyophilic salt, and we know that lyophilic salts behaves as the protective colloid and they protect lyophobic colloids. So we can say that the gelatin is used just to stabilize the colloid and prevent crystal growth. Hence option number 2 is the correct choice.